Hi wonderful viewers, I'm pleased to have you with me once again on this channel, and in this video we are going to take a look at the forces of nature, which are also called the fundamental interactions in nature. Now, physicists have been able to identify four known fundamental interactions or four known fundamental forces of nature. These four fundamental forces of nature include gravitation, electromagnetism, strong nuclear force, and weak nuclear force. So we are going to take it one after the other. Now, gravitation or gravitational interaction is a force which is produced around massive bodies. So every object that have mass produces gravitational field around it. Now, gravity is well described, is more accurately described by the Albert Einstein's theory of general relativity. The Einstein's general relativity theory described gravity not as a force actually, but as a curvature of space-time resulting from massive bodies. However, the Newton's law of universal gravitation is a very good approximation to the Albert Einstein's theory of general relativity. The Newton's theory describes gravity for macroscopic objects. For instance, it gives an accurate description of motions of planets in their orbits and other massive bodies at a macroscopic scale. On Earth, gravity gives weight to objects, and also the gravity of the moon, the gravitational force of the moon, is responsible for tides on ocean surface on Earth. Now, onto electromagnetism. Electromagnetism is actually a unification of two forces: the electric force, which mediates interaction of two static charge bodies, two or more static charge bodies. So a static charge body have an electric field surrounding it, but when this static electric field is described by the Coulomb's law of electrostatics. However, if this charge body is in motion, the magnetic field will be produced in addition to the electric field, and the magnetic force or the magnetic field is well described by the Ampere's law. A unification of the electric force and the magnetic force gives rise to the electromagnetic interaction. Now, for the strong nuclear force, this nuclear force is observed in the nucleus of atoms. It is responsible for confining hadrons into the atomic nucleus. Example of such hadrons include the protons and the neutrons. We also have other subatomic particles within the nucleus called the quarks. Now, a unification of two quarks, a combination of two or more quarks, gives rise to the hadrons. And like I said, an example of hadron is the proton and the neutron. Now, the weak nuclear force is a force which is also found in the nucleus of an atom. Now, this nuclear force, this weak nuclear force, mediates the radioactive decay of elements. It participates in nuclear fusion and nuclear fission observed during the radioactive decay of elements. Now, the electromagnetic interaction and weak nuclear force has been united or have been unified into what we call the electroweak interaction. A major goal of physics is to unite the fundamental forces of nature. So far, a major success has been achieved in uniting the electromagnetic interaction and the weak nuclear interaction. Another goal has been to unite the electroweak interaction with the strong nuclear force to give rise to the grand unified theory, even though at the moment no successful grand unified theory has been achieved. And then the ultimate goal will now be to unite all the four fundamental interactions into a single force. And this single force is expected to explain all interactions in nature. A successful unification of this force will give rise to the theory of everything. However, gravity is facing problem with being described by quantum theory. Thank you for joining me.